Welcome back. Today we're going to talk about dot product of vectors. The dot product is when we have two vectors. So we've got vector u, which is going to be like this, u1, comma, u2, and these are the components, so component form. And v is, I'm trying to make my v super obvious, v1, comma, v2, right? So we got two vectors, and the notation looks like this, u dot v is going to be equal to u1 times v1 plus u2 times v2. Okay, so properties of the dot product. These are some of the things that can happen. So like, we've got products of multiplication, or product like number properties, like when we talk about distributive property or commutative property, those kinds of things. Dot products have some properties as well. And this is where u and v are vectors. And C is a scalar, right? So a scalar is just a number we can multiply by, multiply a vector by to multiply both components. So for example, if we have u times, or u dot v, it's equal to v dot u, okay? So that's kind of like the commutative property, right? Doesn't matter the order. U dot u is equal to magnitude u squared. If I do 0 dot u, it's equal to 0, right? So think about that. So if we've got the 0 vector, so it'd be 0 times the first component plus 0 times the second component. So you'd have, you just end up with 0. Number 4. U times v plus w is equal to u times v dot u w, right? So dot in here. Wait. U dot v plus u dot w. Number 5. So that's kind of a variation on the distributive property with dot products. Scalar times u dot v is equal to u times the scalar times v equals scalar times u dot v. Okay, these are just variations on properties. You'll kind of see them play out as we do a couple of these things here. Okay, so we're going to do just a couple of examples. I'm going to do the first example and the third example here. Got two vectors, finding the dot product. So if I say this is u and this is v, this would be u1, u2, v1, v2. And so to do the dot product, I'd have 3 times 5 plus 4 times 2. So 15 plus 8 would be equal to 23. That's the dot product right there. Okay? Same thing would be true for B. Let's look at C here. So I've got to kind of break down, if I look at, this is that IJ notation. And so what are the components? This would be 2, negative 1, and 3, negative 5, correct? And so when I do my dot product here, I'd have 2 times 3 plus negative 1 times negative 5. And so it would be 6 plus 5 would be 11. Okay, that's my dot product there. So kind of breaking up those things into their components is necessary. So use the dot product to find the length of the vector 4, comma, negative 3. So that goes back to this property up here, right? So we had the magnitude squared. So u times u is the magnitude squared. And so the magnitude of u is going to be, so what we're doing is here, we're going to take the dot product of u times u, and what that's going to give us is we're going to take 4, 3 and dot product it with 4, 3. And so we're going to get the square root of, it's going to be 4 times 4, and then plus negative 3 times negative 3, which is equal to the square root of 16 plus 9, which is the square root of 25, which is equal to 5. Okay, so that's the magnitude, so the length of the vector for -3 using dot products. Now, obviously, if we did the same thing with just finding length, we'd get 5, right? We do 4 times 4 plus 3, -3 times -3, and then take the square root. So that's how the dot product plays in. Angle between two vectors. Angle between two vectors looks like this. We, obviously, when you have two vectors, they go off in specific directions, so you've got an angle between them. And so it's going to be an angle between 0 and pi, or 0 and 180 degrees. And so that's kind of what we have to keep in mind. And you can draw it out, but really it comes down to our, giving a formula. So the angle between two vectors is going to be given like this. The cosine of theta is going to be equal to u dot v over the magnitude of u times the magnitude of v, or the sine, so the inverse cosine, the arc cosine, cosine -1 of u times v over magnitude u, magnitude v, is obviously, so if we have the cosine is equal to this number value, to find the angle, we do the inverse cosine. So what does this look like in practice? Let's take a look here. I've got two vectors, u and v, and I know that I want to find the angle between the vectors. And so I know that the cosine inverse of, and I need the dot product on top, so 2, let's see, times -2 plus 3 times 5 over, so then I need my magnitudes, right? So my magnitude of u is going to be equal to the square root of 4, which is 2 squared, plus 9, because it's 3 squared, so root 13. And the magnitude of v is equal to the square root of, and this would be 4 plus 25, so root 29. So on bottom, I'm going to have square root 13 and square root of 29. And I'm going to take the inverse cosine of those things. So I've got inverse cosine of, on top I've got -4 plus 15, so this would be 11 over square root 13 times square root of 29. And that's going to, when I plug that into my calculator, I'm going to end up with an angle of 55.5 degrees. That's the angle between the vectors, right? And so that's it. That's all there is to it. So you need to find a couple of things. You need to find the dot product on top. This is new, right? Magnitude is old, and then inverse cosine is old. So that's how you find the angle between the two vectors. Orthogonal vectors. Orthogonal vectors are vectors when you do u times v, or u dot v is equal to 0. Okay, so they are they undo one another, and so we want to prove that the vectors u and v are orthogonal. So we're going to do u dot v. Does it equal 0? So I'm going to put a question mark over there. It's asking the question, does it equal 0? If it does, then they're orthogonal. So I'm going to do u dot v is equal to 2 times -6 plus 3 times 4. So it would be -12 plus 12 is equal to 0. So that is proven. They are orthogonal, meaning they have a dot product of 0. Okay? That's all there's to it. That's all we're going to do with this section, guys. Thanks for watching, and we'll see you next time.